Hi, and welcome to Mr. Garofalo's podcast. In today's episode, we are looking at solving inequalities. In particular, today we looked at the specific nature of inequalities as compared to equations. So today in class, we looked at an algebraic inequality, and we saw that different moves put onto the inequality, whether it be a property or an operation, can often produce different results in terms of the solution set. Let's just revisit that concept with a numerical inequality. Consider 4 is less than 8. I think we'd all agree that 4 is less than 8 is a true inequality. Let's try performing some operations to it. Let's say we added the same quantity to both sides. Let's say 3. 4 plus 3 is less than 8 plus 3. Well, this would result in the expression 7 is less than 11, which is true. What about subtraction? Let's subtract 1 from both sides. We would get 3 is less than 7, which of course is still true. How about multiplication? Let's choose 2. 4 times 2 is less than 8 times 2. 8 is less than 16. Still true. So we're maintaining the trueness of the inequality all the way through here. Let's divide by 4. 4 divided by 4 would be 1. 8 divided by 4 would be 2. So the point of this exercise is to examine whether the properties of equality can simply be transferred to inequalities. And on the surface, it looks as if they can. Add, subtract, that takes care of the additive property of equality, right? And multiply and divide, the multiplicative property of equality. However, as we saw, if we use the multiplicative property of equality with negative values, something strange starts to happen. So let's reconsider 4 is less than 8 using some negative values now. So let's multiply 4 times negative 3 and 8 times negative 3. Well, we get negative 12 is less than negative 24. So we went from a true inequality to an inequality that is false. Negative 12 is not less than negative 24. Negative 12 is greater than negative 24. So in order to make this inequality true, we have to reverse the symbol. Let's try with division. Let's say we divided by negative 2. 4 divided by negative 2 would be negative 2. And 8 divided by negative 2 would be negative 4. Well, that's a false statement as well. Negative 2 is not less than negative 4. Negative 2 is greater than negative 4. In order to make it true, we have to reverse the inequality. So again, we went from a true inequality, divide by a negative, end up with a false inequality. Had to reverse the symbol to make it true. So what happens is that when we work with inequalities, the multiplicative property is only true or only works for positive values. When we're multiplying both sides of an inequality by a negative value or dividing by a negative value, in order to keep the inequality true, we must reverse the direction of the symbol. So let's look at where this might come up when we're solving problems like this. So here's a fairly straightforward inequality. 8 minus 2x is less than 16. Let's look at this solved two different ways. One way might be to subtract 8 from both sides. we would end up with negative 2x is less than 8. Now we know from earlier, right? Subtracting, we did that earlier here on this page when we subtracted the same value from both sides. We kept the inequality true. So we're okay so far. We haven't changed the trueness of this statement. But in the next step, if we want to solve for x using multiplicative properties, we would divide by negative 2. Negative 2 divided by negative 2 would be x. 8 divided by negative 2 would be negative 4, right? But since we're dividing by a negative 2, if we keep this inequality symbol as x is less than negative 4, we'll find that those numbers actually do not make the inequality true. For instance, a number that is less than negative 4 would say be negative 5, right? So if we tried negative 5 in here for x, 8 minus 2 times negative 5 less than 16, we would get 8 plus 10 is less than 16. And look at what we're saying. We're saying that 18 is less than 16, which of course is false, which means this solution set has a problem. The issue is that we didn't reverse when we divided by negative 2. Now let's take a look at another way to solve this problem. Another option would have been to use additive properties, but instead of subtracting 8, adding 2x. This would have left us with 8 is less than 16 plus 2x. Then use another additive property here. Subtract 16 from 8, and we would get negative 8 is less than 2x. Divide by 2, divide by 2. Notice we're dividing by a positive number. Negative 8 divided by 2 is 4. 2 divided by 2 would be 1. And we end up with this here. Negative 4 is less than x. If we rewrite that with the variable on the left side, let's say x is greater than negative 4. Well, let's go back to over here. Over here, we said that x was less than negative 4. But we can clearly see by using all the properties we applied on this side that this must be the solution. In fact, we could pick some numbers that are larger than negative 4, plug them in, and they should make the inequality true. So here's further confirmation that we should have reversed this inequality if it was solved in this manner. So you need to be very, very cognizant of this property of inequalities, or this characteristic of inequalities as you're solving. Right, so on your homework, for instance, when you come into problem 9, let's say, you're going to have some important choices to make as you're solving, because some of the terms may be negative, requiring you to perhaps multiply by a negative to eliminate them or divide by a negative. You can avoid that situation by adding to both sides. So we'll start this one together. There's some like terms here on the left side that would combine to negative 6k. So negative 6k plus 5 is greater than negative 7 minus 10k. Now there are certain strategies here that will not require you to have to reverse the symbol. If you are using, if you are adding to both sides, think closely or choose wisely in which variables and which terms you're going to move. I hope this was helpful, and I'll see you in class.